These three matrices have some missing entries. We're going to fill in the missing entries so that the matrices are all symmetric. I'll leave a link in the description to my lesson introducing symmetric matrices. You may recall one of the easiest ways to think about symmetric matrices is that they are symmetric about their diagonal. So in each case, we can picture the diagonal of the matrix and then reflect known entries in order to obtain unknown entries. Of course, the definition of a symmetric matrix is that its transpose is equal to itself. A transpose equals A, that means A is symmetric. All right, let's jump into this first example with this 2 by 2 matrix. If we want it to be symmetric, it needs to be symmetric across the main diagonal. So if we have a 2 over here, we're going to need a 2 over there. And now that's symmetric. Its transpose is equal to itself. For example, you can see that the first row is the same as the first column. The second row is the same as the second column. Then if we look at this 3 by 3 matrix, picture that main diagonal, and then reflect known entries across it to fill in the missing entries. If we have a 3 here, well, we can reflect it across the diagonal. We must have a 3 here as well. You can also think of this as swapping the positions. So this 3, for example, is in row 1 and column 2. So swap those. The entry in row 2, column 1, also has to be 3. That's how that reflection really works. So for example, this 0 we can reflect to fill in this gap. This 0 that we knew was in row 3 and column 2. So swap those. Think about row 2, column 3. That's right there. That's where the 0 needs to go. And of course, we can reflect that 3 across the diagonal to get our final missing entry. And this matrix is now symmetric. For example, if you look at its second column, that's the same as its second row. Its transpose is equal to itself. Finally, we'll finish with this 4 by 4 example. Just reflect the entries. 5 we can reflect across the diagonal and fill it in there. -2 we can reflect across the diagonal and know that this entry here must be -2 as well. Let me just draw that diagonal in case it helps. We can reflect 3 across it to fill in that gap. We can reflect 8 across the diagonal to fill in this gap. Again, if it's not clear exactly where they should reflect to, just think about those positions. This 8 is in row 2, column 4. So swap those. Think about row 4, column 2. That's right here. So that's where the 8 needs to match. We can reflect -4 over here to fill in that missing entry. And then finally, we can reflect the 0 over there to fill in the last missing entry. And now all three matrices are symmetric. Let me know in the comments if you have any questions, and be sure to check out my linear algebra course and linear algebra exercises playlists in the description for more. Thanks for watching.
Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about. Stressed out, honey, I've been stressed out lately. Don't know what's what, don't know what I'm stressed about. Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about.